Great. So thank you everyone for joining us today as we discuss ways that you can outpace and outperform your competition with some proven strategies for successful factory projects. We have a few experts here to talk with you today about this. But before we start talking with them, there are a few logistics that we can walk through. So if you're joining through your computer's audio system and happen to have audio or lag issues, you can try first refreshing your browser or using a new browser. You can also dial in through your phone by clicking on audio settings. As we go through the conversation today, if you have questions, you can drop those into the Q&A section. We'll be standing by to answer some throughout, but by and large, we'll cover those at the end of the webinar. And lastly, this webinar is being recorded and you will receive the recording via email. So feel free to share that with your colleagues. Some more quick housekeeping. During this presentation, we might make statements regarding future events and development efforts on our products and services. These statements are not a promise or guarantee of product delivery. Please don't make any purchasing decisions based on these future-facing events. So with that, I'm pleased to introduce you to our panelists for today. We have with us Mark Banning and Jim Byrne of Autodesk. Mark has spent over 20 years providing strategic manufacturing insights in the automotive industry, and Jim has dedicated over 24 years to inspire engineers to implement tools for 3D design, simulation, and factory planning. They're going to briefly spend some time talking about challenges in the factory layout design process and speak to what it means to implement integrated factory modeling in your company. But we're also joined by a very special guest, Chris Mounts. For over 20 years, Chris has designed, scanned, and modeled factories across numerous industries, including automotive, aerospace, and more. We'll spend the majority of our time today talking to him to learn more about his company and challenges and how PMC has benefited from integrating BIM and factory planning. So one last thing before I kick it over to our panelists today. We're going to have a quick video to preview some of the technology that we're discussing.
Change is a constant in manufacturing. To keep up, factories must be built to undergo a continuous and complex evolution. These changes are often managed by separate teams using fundamentally different systems. Every decision one team makes can affect the other, and vice versa. Any error in communication, file sharing, or planning raises the risk of delays and cost overruns, like a concrete column positioned where a new assembly line is to be installed, or a machine that fits but doesn't have adequate power or cooling. All of these are common outcomes when using disparate systems and inconsistent data. But what if these systems weren't separate at all? What if they were integrated within a single source of truth for every stakeholder? That's the power of Autodesk Integrated Factory Modeling, a solution that connects, organizes, and optimizes all phases of factory projects. Integrated Factory Modeling enables the convergence of information about the building, like MEP and all the machines and production lines. Data management is centralized, standardized, and transparent. No more silos. Everyone works with the same data set in real time from every device. That means you can keep departments and projects on budget and on schedule, using agile, fast-paced collaboration. Digital factories also help you make smarter decisions during every phase of the factory lifecycle, every single day. If you make vehicles, machines, or products, Integrated Factory Modeling can help you launch products faster, increase efficiency, and drive sustainability. Reach out to your local representative to get started.
All right, with that, we're going to get started with our conversation today. So I'm going to pass it over to you guys, Mark, Jim, and Chris. Take it away.
Okay, perfect. Thanks, Michaela. And before I kind of tee it up here, I'd first like to comment on that video that we just saw. If you want to distill that into even simpler terms, we think of integrated factory modeling as having that digital factory or the 3D factory, but also being able to collaborate with BIM or building information model tools. So bringing collaboration and a 3D factory together is really what that whole video was about. And then with that, I'll introduce myself. I think Michaela already introduced me. I have 25 years of automotive experience, actually. And that leads me to introducing Chris Mounts. And I've known Chris for probably 10 years, and Chris has a really special talent that I'm really excited to share with you guys, and that he has the ability, uncanny, to take very technical and complex situations and distill them down into very simple and understandable steps. So with that, I'd like to introduce Chris Mounts and maybe tee things up for Chris a little bit. Chris, can you tell us about your company, PMC? What you do, maybe how many customers you have, what types of projects do you work on, or anything you'd like to share with us?
Sure, thanks, Mark. Yeah, so at PMC, we've been around a very long time, and we like to say we were doing digital twins from the very beginning, almost 40 years ago, with industrial simulation models. Over time, that's evolved. We have almost 300 employees today, and growing. And my particular group at PMC specializes in building out digital twins, often from the ground up with no information. Almost 20 years ago, actually a little over 20 years ago, we began doing laser scanning and converting factories into 3D models using various Autodesk tools, as those tools have evolved over the years. Today, our client base stretches from, of course, automotive, where this is huge, all the way through every kind of manufacturing you can imagine. We've done PEEP factories, we've done oil and gas, every type of manufacturing, every vehicle. We've been in hundreds and hundreds of factories over the years.
Great, thanks, Chris. And we're actually starting to see like how companies like yourself, Chris, are positioning themselves to help not only just bigger companies, but smaller companies become more nimble, more agile. And I think back to my experience. And so we were modeling and or scanning big factories. So usually each shop was 1 million square feet, but a lot of shops are sometimes 10,000 square feet. And I would say in my case, if I was working on a project less than 10,000 square feet, I might do them with my internal resources, but leave the big projects to an outside consultant. But smaller companies might be looking to do smaller projects because they don't even have the expertise. Can you comment a little bit on that?
Yeah, I think, that's a good point, Mark. I think it's evolved over the years here from really a research project that had no return on investment into something that's very manageable, even for smaller companies. And we tend to work on jobs, like you said, that range from 10,000 well into the millions of square feet. And usually it's a pretty different engagement when we're working with the smaller firms, in that we're building them up to hand it off, right? This is not, with the big firms, we tend to have long-term engagements that keep going. With the smaller firms, we're often doing a lot of training, getting their initial model developed, helping them pick out the right tools to get the work done going forward, and then handing it off to them to maintain into the future.
Okay, so we've talked about some of the things that you guys do, the scanning and modeling. What is a typical value that some of these companies are seeing from having these services done? And actually, at the end, I'd like to share some of my experiences around that.
Yeah, I think today the majority of this is focused on the value is in new project work. Whether you're adding a new production line, adding a new chemical to your processing, a new product, some kind of what is going to become a construction project is really where the value has been. And as that continues and as these 3D models get built out, now we're starting to see that transition into the operations side of the business, and more value in that, in the what I think most people consider to be the real digital twin, managing and keeping track of your production.
And we actually, for everybody listening in, myself and Chris were talking about this just before the webinar. And it seems like digital twin was really hot maybe 5 years ago, and everybody was talking about it, but nobody really knew where to get started, and it seemed to dissipate. And I think there's renewed interest because there's been some maturity and stuff there. But I'd also like to add my comments to this. And in terms of value, some of the value that I saw was a much quicker time to market because our plan became our reality, right? In a much more efficient time. So we didn't have all those issues show up during the build phase or commissioning phase of some sort of a plant, right? We didn't have those conveyors running into columns, and that allowed us to get to production quicker. And truthfully, that's where a lot of the money is. Depending on what your commodity is, let's say it's automobiles, it can be $10,000 a minute in profit, right? So getting to production was a big thing. But also capital costs was a big thing. So not having to spend money on mistakes because you caught those mistakes early on. And I think that really was the tip of the iceberg, in that we were doing studies digitally early on. We would catch things that it was only after we really got up to production that we realized, oh, we actually saved $1 million by catching some things early. And it took us a while to learn how to capture some of that. Do you see similar type things, Chris? Or
Yeah, absolutely, Mark. I think you hit it on the head there. Achieving that design certainty, mistakes are costly. I think in a lot of our large partners, that are not into this workflow, they budget anywhere from 20 to 50% in overage cost on their new product construction costs. And we can get those to almost zero with some of these workflows, right? Where the only change orders issued are because someone changed their mind, not because a mistake was made, or not because the field wasn't understood.
It's interesting to hear you say 20 to 50%. I used to have a vice president that would say, hey, if we're within 10%, like we're almost world class. We're pretty much world class.
Oh, for
right?
sure.
So to get to zero is fascinating. So now that we've kind of talked a little bit about some of the values, do you have like an example of where, let's say, 3D saved you or your clients money?
Yeah, absolutely. I can, let me pull some up here and share real quick.
That'd be great.
Okay, I'll give you a second for the screen to pop in. Hopefully everyone can see.
Yeah, it looks great.
Okay. Yeah, so let me kind of walk through what's going on here. As we look over to this side, to our right, I assume it's everyone's right. I don't know if this is mirrored, it might be your left. There were these heat treat furnaces in this manufacturing plant, and they were identical, and the client had installed 5 existing furnaces. And in each instance, they actually raised the roof of the building. They cut the roof out, they stubbed up the columns, built a new truss, framed it out. Right, we're talking hundreds and hundreds of thousands into the millions of dollars per furnace, just in building modifications, not in the actual equipment, right, where you want to put your money. And in this case, what the client saw something when they looked at this, and they said from looking at their existing ones, they thought, this is really close. I think we can get these, I believe they're called soot tubes, and that's this blue thing down here. That was the problem. That tube has to lift vertically out of the furnace, and it has to be done absolutely, with clearance, right? If it hits, it hits. If you can't get it out, you can't get it out. And so we came in and we scanned the area, roughed out the model. The structural engineer played around with collapsing the truss, removing the bottom cord and lifting it up rather than lifting the whole roof up. And we came up with a solution that looked like it would work, right? And in this case, we used Navisworks to actually prove out that it was going to work. Because a lot of these decisions come down to how people feel about something. If there's fear that this furnace is going to show up and it's not going to work and it's going to delay production, it's way better to throw $1 million at the problem and be sure it's going to work than to delay production by a month or two. And in this case, we sat in a big room, we showed it in real time, we moved the soot tube in and out of the furnace. And then some extra benefits too. We were actually able to visually position the furnace, right, and play with its position in real time in the meeting until everyone was comfortable with where it would go. And importantly, this is the real furnace. This is not our kind of mock-up of it. We obtain the data direct from the manufacturer, right? But in real time, we can position this in the bay, right? This is a planning tool. This isn't a CAD tool necessarily. But once everyone buys off on where this position is and how everything looks, then we lock it in, and this actually went out to get the installation drawings prepared. And this furnace went in and it works today. And in fact, they've installed another furnace next to it. In both cases, not raising the roof anymore after raising the roof 5 times.
So it's interesting because I've had experience with truss cuts as well. And generally I used to think of it was $50,000 most of the time per truss cut. And you might have to do 5 or 6 truss cuts. And so sometimes we would find that out ahead of time and we would know, yes, we have to make those truss cuts. But I can remember examples where we were wondering if we could snake a conveyor underneath a truss. We did a study just like this, and we saw that, yes, we had enough space to do it, but we also verified that the people that were working on the ground interacting with that conveyor, it was not too high or too low for them. So you can also bring it into human simulation. But I'd like to point out that, Chris, you mentioned $1 million, they would spend to maybe raise the roof or so. In this case, you didn't have to spend that $1 million, but you also didn't delay that 1 or 2 months time, right? So you got up to production quicker. You also saved that $1 million. So it's really a win-win.
Right, and that comes with a comfort level, right? Because we can prove all this out mathematically and draw it out, but when you can sit in a meeting with executives, they can understand what they're seeing on the screen, right? And we show that soot tube actually coming out, then they're comfortable. And then they believe what they're being told, that in fact, yes, you can get away with not raising the roof. This isn't going to shut production down. We can make this work.
Great. And then you're showing some examples, like this is kind of in the planning phase. But what would be a typical starting point? And I suspect there's more than one answer for factory digitization, like scanning or modeling or anything. What are your thoughts around that?
Yeah, I think we've started very early with a lot of customers. I have another example to show here. This one was, I consider this our first, what I would consider a real 3D factory. We'd done little odds and ends before this, but this dates back to very late 1990s, going into the project ran into the 2000s. So we're talking more than 20 years ago that this was made. And what you see here, right, is kind of a messy combination of 2D and 3D and really selective modeling to get the highest value out of it. And I guess what my takeaway here would be is when we meet with a customer that's new to this and they're just getting started, is just get going, right? You don't have to convert your whole enterprise overnight. You can take your time. You can just get one of your teams working in 3D and it will grow organically. Because once even one person in your organization is doing this work in 3D, you're going to see success, right? And success breeds success. The person sitting next to them says, hey, I want to be doing that too. This is working, right? And it will start to grow organically. Don't get overwhelmed. Don't think you have to abandon all the software you have, right? I think we even saw in that poll, right? AutoCAD is still king in this space. And probably will be a part of this work for another decade at least. But get going in 3D, get a tool that can do 3D and start roughing out your plans, start focusing on high value areas. And here you'll notice it was really the production line areas where operators would interact. That's where the money was being spent. That's really where we historically had saw the most change orders. And so that was the focus, was to lock those areas down. Like you alluded to, Mark, simulation, human simulation, ergonomic simulation, all of that was done based out of these models. that would feed out into all these different strategic groups within the organization. And to be honest, all that started on this job with one area, one little 40-foot each, 2 stations for engine load is where we started. And then over time, this grew out of that because they immediately started seeing success with the cost avoidance on just that one little area. And we kept going with it, kept going with it. And over time, you know, it became the better part of the factory got roughed out.
Can I stop you there for
Yeah.
just for a second, Chris? So if you go down to the factory level, and I will make a comment, like this is 20 years old and there's a fair amount of detail there, but a lot of the models that I'm seeing now, like it's unbelievable the level of detail that's there. But
This is pretty primitive.
yeah, and when I look at like all the racks and stuff there, and we're talking about, hey, where do you start? You mentioned, hey, this started with a 40-foot section and get started. I'll add my 2 cents in that. One of the things that we found really beneficial was starting to create a library of all those objects that are on the floor so that you can put them in very quickly, right?
Yep, absolutely.
Yeah.
An asset library is critical.
Yeah. And in fact, we used to measure, hey, did we have all of our tools and all of our material handling things? That used to be like a KPI for us. But I'm also going to ask you, like, do you typically start with a scan and model on top of the scan, or will you sometimes not use a scan? Like, what's the benefit of starting with a scan?
I think history has shown that the scan is going to be correct, right? And almost no other source of input data on a factory floor is going to be correct. We have study after study after study we've done that shows, you know, your 2D drawings are not correct. Anything you think you have is just not correct. And that causes problems, right? If you really want to do this, you want to make sure you don't have those change orders coming in, that added cost. What you start with has to be correct. That said, sometimes that's not something we can do. There's price considerations, things like that. You know, a lot of this plant was actually done from conversion of 2D data. We used to actually take 2D sections and stand them up vertically to kind of visualize, you know, try to piece this together, try to find those problems ahead of time. Nowadays, it's much more common, right? For those who don't know, right, this is what a scan would look like of a cell, right? Very, very high accuracy data. Pretty much impossible to make mistakes when you're doing CAD because it lays right on top of the scan and you know exactly what you're getting into.
Great. I'm not sure. Are you able to switch over to CAD for this one, or?
Yeah, yep. Yeah,
Like
it's just
to give
hidden
the
right now.
audience an idea, right? Have, okay, here's the CAD and then here's the output, right? Perfect. Yeah.
Yep. So you see the CAD is more basic, right? Like you said, Mark, we can put a lot of detail in here, but when you're dealing on the factory level, you still need to keep detail where it matters, right? And focused. If we put all the high detail end effectors and tooling in here, straight out of those design software, it would bring this model to a grinding halt.
Yeah.
But selectively we can. And in this case, what happens is our model will feed into the simulation models, and then they attach those high detail end effectors, you know, weld stations, and things like that to it.
Yeah. And then they're only simulating just that station typically, right?
Yep, exactly. Yep.
Yeah. And I'll go back to a comment that you made before, that your 2D is almost always never accurate. And I can attest to that. Like when we first started going from 2D to 3D, first of all, it was always a challenge to find where the 2D was. And that's something I think we might get on talking about a little bit later. Finding digital data is I call it one of the digital wastes. But when we took those 2D AutoCAD layouts and we started building 3D layouts and we did our scanning, those columns were off and off by a foot, like it was on the 2D drawing, right? So
yeah, it's amazing how far even something that's manually measured, you know, it's really easy to transpose a note on a piece of graph paper from an 8 to a 9, right? And just shift a column a foot. right? That's an incredibly easy mistake to make. And we see that over and over again. And scans have just gotten incredibly cheap over the years. It just makes sense to do this in most cases.
Yeah, and I'm actually gonna kind of go off topic a little bit here. In terms of scanning, like, are you finding companies sometimes have internal resources, or do most companies hire somebody like you to do that? Or what are you finding now?
I think the larger the organization, the more likely they have their own equipment internally. And then we come in to kind of supplement. For most companies, it would make no sense to have a massive scanning organization. They don't have a consistent enough workflow to employ those people. Some do though, but for the most part, as you get to the smaller manufacturers, they don't have that, and really shouldn't, right? This equipment is expensive to maintain and take care of. The initial cost can be quite a bit. Versus, there's a lot of, let's say I have a lot of competition in this space now. So you
Yep.
can get a pretty good price on getting scanning done. Yep.
Yeah, for sure. And I would say, because I did have a scanning team, but I would never tackle a big project on my own, just because I needed the
Yeah.
resources. Like, sometimes you need 6 or 7 people if it's 1,000,000 square foot to do it in a weekend or a week, right? And we just didn't have that kind of manpower.
Absolutely. And in modern manufacturing, especially nowadays, right, there's no downtime. So it's, hey, we're out of parts this week. Get my entire factory done on Tuesday and Wednesday.
Exactly.
Okay, we got a field, like you said, a team of 8, 10 people with, matching equipment to get down there and scramble. Yeah.
Great. Thanks, Kristen. I think at this point, I'm going to invite Jim to kind of come in and participate a little bit. Jim, what are you thinking? Or you have got some questions here?
Yeah, yep. I do have some questions for Chris, and then I guess my questions may be a little bit different than what Mark had, just because my background is more on from a technical perspective over the past 20 some years. I've trained software and I've supported it, and here at Autodesk as a product marketing specialist, my questions will probably dive a little bit deeper into the solutions that that Chris is familiar with. And then Mark, one of the other things too is I like all the interaction that you've had and the experience that you've been talking about. So I just want to make sure that if you have any thoughts on these two, that you feel free to chime in.
I will if appropriate, and if Chris lets me.
Yeah.
So Chris, you've talked about how the hundreds and hundreds of factories that you've been in over the past 20 years. Just wondering if you could tell us what are the top tools, maybe the top 1 or 2 tools that that you couldn't do without, that you have to have. And you've already alluded to some of that, but I wonder if you could expand on that, and maybe what the biggest impacts have been on those tools that you're using.
Yeah, I would say, if you would have asked me this a couple of years ago, I just would have said there's only one. It's really Navisworks, right? That's where everything kind of comes together and merges, and that's what we've been looking at here. A tool that lets me. This is a 1,000,000+ square foot manufacturing plant, and I can just spin around in it like it's nothing, right? And when you're trying to coordinate an entire project, this is invaluable. Right, I can throw point clouds in it. I can throw in pretty much every software CAD design product on earth. I can just dump into Navisworks and position it. That the furnace we were looking at earlier, that furnace came from SolidWorks, and we just brought it right into Navisworks, made it fit. Right, ultimately drawings were then done in AutoCAD based on it, and this has been kind of the mainstay of factory work for a long time, because factories involve so many people, so many different software products. This is the merging point of it all, and it's spectacular. Now in current day, right, as things have evolved, there's new options, right? And I think Construction Cloud is transformative, right? Before, it was such a challenge for us when we would do these plants, right? It takes a long time to model 1,000,000 square feet. And seldom is that time allotted in anyone's schedule for a new program. So in the past, this was just a struggle of like shipping half-done files and then pushing updates out to the customer through FTPs. Construction Cloud means we can work on these live and keep pushing data in while the program, the new product, new whatever is being made, well, they're actively working in the same data set as us. And we can share that, and coordinate. It's so powerful. As far as what it's able to do in compressing schedules, as Mark alluded to, I think in manufacturing, a schedule is more important than money, right? I mean, ultimately, the schedule is money, but people are willing to spend a lot of money to compress a schedule because the sooner you get that product coming off the line, the better. And of all the tools and all the time I've been doing this, Construction Cloud really compressed that schedule the most.
And I'll add to that a little bit, like some of the things that we're seeing gain in Construction Cloud in terms of automation of aggregating some of this data. So think of having a repository for each of all that what we call silos, the different groups. So material handling, your conveyor team, your facilities team, the people that put all those computer terminals in the right places, et cetera. Working in their own workspace and then putting it together. You used to maybe pay somebody to go and get everybody's data and bring it all together in Navisworks. Some of that's now automated inside of Construction Cloud. And I'll also say it's not just about the 3D models, but there's other things that you can do in the Construction Cloud as well, like checklists for those daily meetings that you do. Or let's say if we're talking factory, checklists that everything is in that workstation that you're looking at, right? And you have 20 stations in your factory. Sometimes people have 400, and you have each of those with a checklist in the Construction Cloud, and it's a simple form on a phone that you fill out and it reports to a dashboard, right? So there's other benefits as well.
Yeah, it's huge. And we see that on a lot of, when we start sharing this with the customer, they start rolling out those features as well. Right. I think, like you said, data discovery is enormous. Right? I've seen studies that say up to 30% of an engineer's time is spent searching for data. Right. And yeah, if you can streamline that, which it does, it's huge. Yeah.
Chris, I'm seeing this perspective that you have up on the screen for the first time. I think it's just enormous.
Yeah.
A million square feet. Do you happen to have an estimate of how many parts are in this data set that you're looking at?
Oh, I couldn't guess. It's hundreds of thousands.
Yeah.
Yeah.
And so the other question that I have is, you've been talking about communication with your customers, sometimes live when you're looking at models. I'm just curious to hear more about your experience with collaboration, especially since you talked about using cloud products or using Construction Cloud. How has collaboration been? Is it something that's been increasing over time? Is that something that you've been promoting more in your business?
We see it as absolutely critical to our business, right? From a schedule perspective, it's enabled projects that we probably wouldn't have been able to do, right? If we tell a customer it's going to take us 2 months to model your factory, they just say, sorry, we're going to stick in AutoCAD. We can't do it. But when we say you can have this first area in 2 weeks, and then every day more data is going to flow in and you're going to see it, it's huge. And then for us, it's also about the real-time feedback, right? At first, it's a little scary to open that up and have other people see your work in real time. But what we found in general is the more people you can draw into that process, the better, right? And the earlier you can get them engaged, the better. And what we found is a lot of times it's actually reducing our work, because the customer will come in and they'll look at this incredibly detailed thing that my team built, and they post a comment like, no, we don't need that. We need something more basic. Here's what we're trying to achieve. right? And we can get that real-time communication back and forth, and it's huge. And then this, of course, translates out into the construction projects, right? If the contractor can see this ahead of time and start making plans, and obviously this shakes up that whole industry, right? But it helps, right? It can be a little scary at first, but it helps.
Yeah. And as you had mentioned AutoCAD, people who are using AutoCAD, and you had talked about this earlier too. In fact, we saw in the poll, the audience didn't get a chance to see all of the answers in that poll, but AutoCAD was dominant. And so you had said a little bit about this for those who are using AutoCAD, and for those who are on the call, if they are using it, that's their primary tool. What would you say to them as we talk about some of the tools that you're using?
I think, like I said, AutoCAD's going to be around for a long time. And here's that same weld cell that we were looking at earlier in Navis in 2D AutoCAD. In particular, this job is done using factory design utilities that links AutoCAD, Inventor, and Navisworks in a really neat way that allows you to keep working in AutoCAD and then synchronize it back to Inventor and Navis. But I think the key is just get going, right? Get some kind of 3D product in-house and start your transition, because at some point in the future, you're not going to have your factory in 2D, right? You're going to manage it in 3D. And the sooner you can kind of get started on that journey, the sooner you get to that point. I think, we talked about this a little earlier, right? We see this constantly with clients. I want a digital twin and I want to manage my entire operation end to end in the digital twin, right? Literally no one on earth is doing that yet. But it's going to happen, right? And the sooner you start to get this process going, you don't want to end up in a situation where your competitors are completely digitally managing their operations and you're still in AutoCAD, right? With that said, if you are, there's a transition path, right? We saw it in, the large factory, right, where there's still a tremendous amount of 2D information that's being merged in together. There's not a ton of value like here converting the office space to 3D. If you're a manufacturing customer, who cares? Leave it in 2D, it's fine, right? Other lower value areas, right? But just get going. And quite frankly, you can do 3D in AutoCAD. We actually started doing 3D in AutoCAD because we just didn't have access to other tools at the time. And doing the 3D in AutoCAD is what led to showing that good return that facilitated the budget request to get the better tools and do even better things with it, right? The fundamental, I think, issue with AutoCAD is what Mark talked about earlier, assets. AutoCAD, you can fake some stuff with blocks, but it's never going to be an asset-driven solution like FDU or Revit is, where every object is this smart asset. It knows what it is. We can schedule it. We can tag it. You're not going to get to a stable working environment in AutoCAD using that, right? You can do some neat stuff with blocks, but you're never going to get to that level of, true asset integration.
Yeah.
I just add a simple comment in terms of AutoCAD. So when we first started transitioning from AutoCAD or 2D to 3D, we used to just tell the people that were approving our expenditure for 3D digitization, we were just showing them an example in 2D. Can you tell if this column that's 11 feet or this rail that's 11 feet in the air is going to interfere, right? Because it just looks like a mishmash on 2D, but in 3D, it becomes very clear where it fits in space, right? So,
yeah, yep. And I was thinking too, as you were mentioning that we had that poll that came up to see what some of everyone is using in the audience, if they use PTC, if they use NX, or I don't think I saw SolidWorks in there as an option, but some of you may use it. And just wanted to point out that whether you're using Inventor or you're using Navisworks, it's pretty CAD agnostic when it comes to the types of models that you're working with. that you can bring in all of that. And you were alluding to this earlier, you can bring in all of that data and it actually remains associative to the original model, whether you're in Inventor or you're in Navisworks.
Yeah, that's an amazing functionality. It's led us to abandon a lot of, we used to have a license of every product out there specifically to do these exports and integrations. We've let almost all of them lapse now because Inventor just takes care of it. Yep.
Yeah. Yep.
Yeah.
And I think I just have one other question for you. And we know that, you've been doing this for a long time. And we also know just from talking to you that you spend a fair amount of time, looking for ways to improve on your own processes or ways to innovate. Just wondering what you think is the next evolution of digital factories.
I think it falls in a lot of different factors here. We're working pretty closely on some machine learning to extract things from the point cloud automatically. That would be a big transformative move. Still a ways off, right? But we're making progress there. I think the big one though is getting to that dream digital twin, which is taking the geometry part of a digital twin is pretty much solved. Right? We can build out huge models. We've seen them today. We can get the geometry done. The next step is to get those data layers applied on top of the digital twin. And with products like Tandem that's coming up and a few others. And just, 2-3 years ago, this wasn't realistic. And only in the last couple of years have we seen some industry standards start to come together around that data collection, data indexing. This facilitates all these huge value workflows like predictive maintenance, right? Predictive maintenance and deep machine learning on tooling and equipment is going to reduce people's costs in a way that really hasn't been seen before. And all of that is starting to become realistic. And we have a few customers where we've seen it done on specific systems and specific tooling, but to do it on the broad scale of really digitizing your whole factory and pulling in all that manufacturing information. We're seeing a little bit on our simulation business of simulation models that are pulling in real-time production data and then projecting your yearly output. Right. And really getting smart about that and analyzing it and predicting more in real time. That is clearly the future. And it's quite frankly, really exciting to see where that takes us.
Yeah.
Yeah. I'm going to add a little bit to that, Jim, in terms of like one of the things that I see really evolving, and we've talked about it extensively already though, but is just the ability to collaborate. And I think, one of the earlier questions is where can you start? Like, do you start on the factory side or can you start in collaborating? You can start collaborating right away and you're already probably collaborating in other softwares. I'm just thinking like Google Sheets, right? But it's the same kind of thing for a factory. You can do that same kind of collaboration now, particularly using construction cloud products. So I myself see a lot of trends there with things starting. And I think some of the machine learning that Chris talked about, we're starting to see lots of companies have data scientists on staff, right? So they're going to be the beneficiaries of having a 3D model. They're going to use that to visualize some of that learning, I think is what you're going to start to see. They're going to click on that robot and it'll take you to wherever the data is for the machine learning for that robot, right?
I think the 3D model is a critical component because we're all overwhelmed by data. And the 3D model is a great way to digest that data. Yeah, I think you brought up, Mark, with collaboration. I know you guys have a partnership with a simulation program, and we talked a little bit about that. Sorry, I forget the name now, but it's the first time I've seen a simulation program that's linked directly, in this case, to the AutoCAD data. And so it updates in real time. And that's so important to the value of industrial simulation. I think a lot of people don't appreciate just how important that is because factories are alive. They change daily.
Yeah. And I
Yep.
think that product is Pro Model, if I'm not mistaken,
Yep.
that you're thinking of. But I also think you're going to see a lot more integration in the future, and it'll all become more of a platform, right? So data will be very,
Yep.
you won't have to exit one program to go to another, right? It'll be
Absolutely.
more
Yeah.
integrated.
Okay. Michaela, do you think we should jump into a few of the questions that have come up?
Yeah, we do have a couple, and that's probably all we really have time for today. The first question we have from the audience is, how are you using factory design to incorporate assets in a way that will feed into the end user Revit model?
That's a complicated question. So I think, in general, Mark talked about this a little bit earlier, assets are critical in being effective in this workflow. And for us, what that means, because we support a lot of different people on a lot of different platforms, we maintain multiple asset libraries across the different products. I've kind of been, quite frankly, caught off guard with the traction that Revit is getting in the manufacturing space. And we're under a huge push right now internally to port our library over to Revit. And this is not a simple task, right? These aren't dumb objects. They're very smart, complex, in this case, families in Revit that we've over the years built out in factory design utilities. These have an enormous impact on how productive you are. It also has an impact of standardizing for a customer. For us, our customers can standardize on what is allowed in their factories to help keep, spare parts and things under control.
Yeah, like you can export into Revit, but it doesn't bring all that smart data with it. But what I can say, and we did have the safe harbor statement. I know there's been discussion about ways of doing that within Autodesk, right? And I can't say much more. But it's certainly, it's something that I think we're aware of.
Yeah.
Like bringing all the metadata along, right? When you convert.
Right.
Thanks, Chris and Mark. Maybe our last question for today, because I think we're running a little over time already, is someone's wondering, Chris, what type of scanner are you using for gaining point cloud data?
We mostly use Pharaohs, but we're transitioning over to mobile units from Naviz for some work, just because it cuts the cost more than in half to do capture.
So
Gotcha.
just for the audience that's out there, Chris, can we talk about, because you're going from Pharaoh to Naviz, so like the big players in the terrestrial scanners or scanners that are on tripods that you move around, it would be Pharaoh and Leica. And then Naviz is part of what we call that SLAM technology, or simultaneously locating and mapping, where you're actually walking behind the scanner and it's aggregating the data as you do it, right? So it's much quicker, but the hardware is more expensive, right? But they're
and the accuracy is not quite the same, right? So it's, even when we do that work, we still supplement with tripod scans. There's a certain homogeneity in the tripod market, right? Whether you have a Leica or a Pharaoh, the end data that's output is about the same, functionally speaking, right? There's of course details and differentiators, but in general, it's about the same. Naviz is very different, right? The data looks different, but it's good enough in a lot of cases for, quite frankly, half the cost. Yeah.
Great, thanks, Chris.
Thank you to all of you. Chris, Mark, Jim, it was really great to hear from you all today. I think with that, we're going to go ahead and wrap up. If you're listening today and you'd like to learn more, you can let us know in the poll if you'd like to have someone reach out to you, or if you check in the chat, there's a link over to a page where you can learn more about integrated factory modeling and some of the technology that we talked about today. So thank you again, everyone, for joining, and have a good rest of your day.